Assalamualaikum and good morning everyone. I am Amira Idrina binti Muhammad Amiruddin. Today we want to do a video about experiment 5 physics, frictional force. The objective on this experiment is to determine the coefficient of static friction from different surfaces. Next is apparatus. The apparatus is wooden block, rubber covered at one side, 5 grams of masses, 10 Newton spring scale, string and tabletop. Next is procedure. Number 1, measured the mass of the wooden block, recorded a mass. Number 2, the apparatus was set up. Number 3, the tabletop has to be stable and horizontal to the ground. Number 4, the spring scale was attached and the wooden block with string. Place them horizontally on the tabletop and the rubber side of the block is face downward. Number 5, place a M equals to 50 gram mass on the wooden block. Number 6, the spring was pulled slowly. After the block started to move, the spring scale's reading was recorded. Recorded the value as F's and tabulate in the table. Number 7, repeated step 4 until 5 for 3 trials. Number 8, 50 gram mass added on the wooden block and repeated steps 5 to 6. Repeated the step until a total of M equals to 500 gram mass is on the wooden block.
This is the result for the rubber surface towards the floor. The mass of the wooden block towards the rubber surface is equal to 0.63, and then for the mass 50 for try 1, for the static friction force we got 1.0, and then try 2 we got 0.8, try 3 we got 1.0, and then we add the 3 trial and divide by 3 to get the average, which is 0.93. In this table of the result, we can conclude that the higher the average is the higher static friction force. And next is the result for the non-rubber surface facing the floor. For the mass 50, we got the static friction force. For trial 1 we got 0.2, trial 2 we got 0.4, and trial 3 we got 0.4. We calculate and then we get the average 0.33. As we can see, the non-rubber surface is same with the rubber surface because the higher the mass, the higher the average of the static friction force. But the difference is the wooden block move faster when it's facing the non-rubber.
For the analysis data, number 1, draw and label the free body diagram of the wooden block.
Next, in the slides you can see that the graph of static friction against normal force for the rubber surface. This is the graph of static friction against normal force for the non-rubber surface.
Number 3, use the gradients obtained from the graph to calculate the coefficient of static friction mu for each surface. Number 4, compare and discuss the coefficient of static friction obtained. The coefficient of static friction obtained for the mass of a wooden block with a rubber surface is 0.3946. Meanwhile, for the mass without a rubber surface is 0.4853. A higher coefficient of friction means that more friction force is present relative to normal force. Static friction is a term we use to observe the fact that it usually takes more force to set an object into motion that it takes to keep moving once you have got it started. This means the mass of the wooden block with a rubber surface needs less force to move the wooden block than the mass without a rubber surface. Now we proceed with the questions. Question number 1. How can anti-lock? Now we continue with questions. Questions number 1. How can anti-lock brakes stop a car in a shorter distance than regular brakes? Salah. Now we proceed with the question. Question number 1. How can anti-lock brakes stop a car in a shorter distance than regular brakes? In anti-lock braking system, your car wheel speed is monitored, and if wheel lock is detected, a sensor sends a message to a controller that releases and applies the brake up to 20 times per second. Number 2. From your experiment, which material has the highest coefficient of static friction? The highest coefficient of static friction is the wooden surface. This agrees with our hypothesis, which states that wood surface have a higher coefficient of static friction is determined by the normal force of the object acting on the surface. Wood surfaces are rougher than smooth cement floor surface. Therefore, the normal force exerted by the object on the wooden surface is greater than on the cement floor surface. So, the force applied to pull the object is also greater on the wooden surface than on the cement floor surface. Question number 3. Once the mass begins to slide, does it move smoothly or does it undergo stop and go motion? Explain the motion. The mass moves in a stop and go motion. The wooden block will rub against the floor, which will cause a friction to be happen. Thus, the friction will grip the wooden block from moving freely and cause slow pace movement till it stops naturally.
The purpose of the experiment is to determine the coefficient of static friction of different surface. The friction force will increases when the mass added increase. After evaluated, the coefficient for the wooden block that has rubber surface toward the floor is 0.4853, while the coefficient for wooden block that has no rubber surface toward the floor is 0.3946. In this experiment, there are few reasons to get an error for the data. For example, random error due to the uneven surface of the table used. This error can be avoided by taking several readings during the experiment to get the average value of spring scale. Other than that, there could also be a parallax error and can be prevented by positioning the eye perpendicular to the reading scale. In conclusion, the coefficient for the static friction of different surface was determined. The coefficient for the rubber surface is 0.4853 and the coefficient for the non-rubber surface is 0.3946.